Okay, well, last time we looked at how to program concurrency in our two different languages, C++ and Java. And today what we're going to do is we're going to continue specifically with the Java programming language. And we're going to look at several examples in the book by Sestoft. And our eventual goal is to understand how exceptions are handled in Java, because in order to run concurrent processes in Java, you need to understand how exception handling works in that language. So that's going to be, so what we'll do at the beginning now is we're just going to run through a whole bunch of simple little examples from Sestoft. And I think a lot of you guys have seen this if you've done the big Java project that we did in the computer systems course. You will have seen all of this before. All right, so the first one that we're going to look at is this one up on the slide, Sestoft example 10.java. He numbers all of his examples, and we're going to take a look at number 10. And the thing we want to illustrate here is the Java string type. And the Java string type is immutable, which means what?
Changeable or not?
Immutable.
Not changeable.
Yeah, it means it can't be changed. And so actually, do you remember we talked about mutability when we did scheme? Do you remember lists in scheme, list processing in Lisp? And in pure functional programming, all lists are immutable. So you can't, we never did do like insert something in the middle of this list. The way you would insert something in the middle of an immutable list is you copy the first part and then put the element in there and then copy the other part and make a new list. So you do it with copies. All right, and the two methods that we want to illustrate with this immutable Java string type is char@ and length. Now, what do you suppose char@ does? Caret. Right, it's a string of characters, and so you give it an integer, the position in the string, and it returns the character at that spot. So that's like the subscript. Yeah, it's called char@. And then length obviously returns how many? Oops, wrong. Okay, so here's the code. Here's the first one that here's the first one that we're going to demo. It's example 10. So class example 10, public static void main string. We're not going to use the command line arguments. And now, what's the very first thing he does? He does system.out.println eCount. And then he gives it the empty string. What is eCount? Well, that's this static int eCount. So eCount, is it void, yes or no? Is it void, yes or no? No, it returns what type? Int. It returns an int. And what does it take as the parameter? A variable of type what? String. So this is a Java string, capital S string. That's a Java string, which is immutable, right? And so he's passing the empty string here. The next time he calls eCount, what is he passing? A string HJSDAFJ space YEWEQ, look, right? So that would be S. And whatever string he counts, or whatever string he passes into this eCount, what does he do? Int eCount gets 0, and then for int I gets 0, I less than what? S.length, I plus plus. So first I is going to be 0, then 1, then 2, then 3. And then if S.char@I equals E, what does he do? Okay, so let's plus plus, so what is he doing? He's counting the number of E's. So let's predict what the output's going to be. Can we predict that? What's the output going to be? Hello? What's the output going to be? When he calls the first eCount, it's going to be 0 because there's no E's in that one. What else? Then what's the next one going to be? 1, 2, 3. 3 or 4? What do you think? Is uppercase E equal to a lowercase e? Probably not. So what would the next one be? 4. And then what was the next one? 1. Is that our prediction? Okay. Let's try it. Here comes our demo. Okay, this is going to be a very short demo. All we're going to do is, we've seen the code already. Let's right-click on this and run it. Ha! 0, 4, 1. Is that what we predicted? All right. Is everybody good? Does everybody see how that worked? Okay. So here, example 11, arrays of string. Now this one we're going to do compare to. So if A is a string and you do A dot compare to B, that returns a positive integer if A is greater than B, 0 if A equals B, and a negative integer is if A is less than B. And what do you think we mean by greater than and less than when we're comparing strings? We mean what order, do you suppose? Length, how many characters there are? It's alphabetic order. So let's see if we can predict this. All right, so here's Sestoff example 11. And what does it say here? He's got, now, do you guys know how this, can somebody tell me what this brace, comma, 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 brace is when we say string, bracket, SS0? What's that? What's happening there?
Inputting each of those strings into the array.
Yes, the fact that we have a string with square brackets means that this variable, SS0, is an array of strings. And this is the Java way to initialize the elements of an array. Is everybody with me on that? So it puts the empty string at SS0 sub 0, the string A, B, D, E at SS0 sub 1, and so on. Are you with me? And now, and then what does he call? System.println what? Sorted. And he's going to pass this array of strings. Now what does this sorted going to do? Notice that the parameter for sorted is A is an array of strings. And he does what? For int I gets 1, I less than A dot length, I plus plus. I gets 1, I less than A dot length, I plus 1. So what's he comparing? The first time I is 1, and he's saying if A sub what? Which is? If I is 1, this is, if A sub 0 dot compare to A sub 1 is greater than 0. So what's he comparing? If that's, what did we say that compare to does? If it's greater than, what did we say that? If it's greater than, then what happens? Then A is greater than B. So if A is greater than, so if, does everybody see that if A sub I minus 1 is greater than A sub I, are they in alphabetic order? Is the list in alphabetic order? Yes or no? Okay, well what makes it, okay, it's like this. It's like this. If this is apple, on the alphabetic order line, if this is apple and this is like bear, then these are in alphabetic order. Bear is greater than apple.
So does that return a positive integer?
Well, here's the specification. It's if.
It says A is greater than B. I don't know.
But by greater than or less than, we mean apple is less than bear because in alphabetic order, it's to the left.
Okay.
You see what I mean? The order is alphabetic order on the number line if these are strings.
Okay.
Is everybody with me on that? You see what I'm saying? Okay, so now is to see what now. So what can we predict what comes out here? Can we predict what comes out? Because this is going to compare A sub 0 with A sub 1, A sub 1 with A sub 2, A sub 2 with A sub 3. Are you with me? And if ever this one is greater than this one, it's going to return right away what? False. But if not, it's going to go through this loop. It'll never return false. And after it ends the loop, it's going to return true. So are these in alphabetic order? Just tell me if those are in alphabetic order. So this is yes. What about if it's just what? If it doesn't have any, is it in alphabetic order? Yes. If it just has one, is it in alphabetic order? And is B A and A B B B in alphabetic order? No. So what should happen? What should come out? True, true, true. True, 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 false. Is that our prediction? All right, let's go back to our example 11. And now we won't look at the code. We won't take the trouble to look at the code. We'll just run it. And look there, you guys. Here is our demo. True, 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 false. So everybody, oh, this is interesting, isn't it? Let's take a look. Let's examine the code again. The question was, I thought it returned numbers. Look, what happens is compare to returns a number which is then greater than 0 or not. But sorted returns Boolean, so it either returns false or true. So the false or true is what gets printed out here. And notice that with Java, you can actually print out a Boolean directly. You can't do that in C++.
It's not comparing whether each element in the list is in
It's the whole list is in alphabetical order.
Okay.
Because once it gets to one where it's not, the whole thing is not in alphabetic order.
Well, because if you put like A, B, D, E, A, B, D, F, like how is it comparing those two?
According to alphabetic order. So ask your so if it's what? If it's A, B, single letters?
Oh, I'm just looking at like the first one. A, B, D, E, and
Oh, A, B, D, E is to the left of A, B, in alphabetic order is less than A, B, D, F. Oh yeah, it does that. Because the first letters are the same, but then the E is less than the F. So that's alphabetic order. Are we good? Okay. Is everybody following this all right? Oops. Let's go back here. Okay. Now, this next one shows this CoSc example 12.java. Now here's one. Now you guys, I had to actually modify the code for CoSc here because I wanted to give you guys access to all the software in a NetBeans project. So, and I also, the two things that I augmented his code by is, first of all, I put everything in a package. Now, do you guys know the concept of a Java package? Has anybody here done Java programming with package? Okay, so what happens is, when you use more than one class, what you do is these the Java standard, as specified here, the Java standard is each class is in its own separate file. So in our data structures program, in C++, we frequently combine two different classes in one file. But with Java, you always have, it's one class per file. And and so the question then is, how does one class use another class? And the answer is, you organize them by putting them in the same package. So what I've done here is I have put CoSc example 12.java uses CoSc example 24.java. So I have actually put those in the same package. All right, and I'll show you in how I did that in NetBeans. All right, so the developer convention is each class is in its own file. And then here, the other thing that this example is going to demo is plus is concatenation for type string. And the other thing is, there is this toString. And toString is the standard method that's called when you output an object. So you don't actually have to say toString. You can just, when you just output the object, if it has a method called toString, that's called automatically. Are you with me on that? So let's see how example 12 looks, how that looks in our demo. All right, now watch this. So this time I think we'll open example 12. Now watch. So here in NetBeans we have example 12, and here is our, see, this is the project node. You got the files node over here and the project node here. And here, if we open up our source packages, now you see example 12 is the name of the package, and here there's two files, example 12.java and example 24.java. Now what I've done is, here I'll show you how I modified the code a little bit. So here is example 12.java, and notice that it starts here with package example 12. All right, And what does example 12 use? It uses this class called point. And how does it know what point is? Well, if you go to example 24.java, what happens is we have in package example 12, we have class point. So now our author does not follow this convention of having the file name be the same as the class name. So that's something that he does differently, all right? But in order for example 12.java to use class point, what we do is we put them in the same package. And this package here is this package example 12, all lowercase letters, corresponds to this source package right here. So these two are in the same are in the same package. Does everybody see how that works? Now, just organizationally. All right. So now let's go back to our slides and take a look at the code. So now, here's class point, and what are these called when you have a class and then you have some variables inside that class? What is that called in UML terminology? Those are the what of the class? Those are the attributes, right. Okay, so these are the attributes, the two attributes, x and y. Each one of these is an int. And then it has methods, right? So attributes x and y, and so here at point, this is a function with a method with the same name as the class, so it must be the what? What is it in C++ when you have the name of the function is the same as the name of the class and it doesn't have a type? What is that? That's the constructor. And notice here that this is interesting. This constructor has an x and a y. It has an x and a y in the parameter list of the constructor, but also it has an x and a y as the attribute. So how do we distinguish? Now, in our convention in the data structures class is to have every attribute starts with what? Underscore. But Sestov doesn't have that convention. Are you with me? So, in fact, in this particular case, this x and this x have the same name. So when you use the word x in the code down here, how do you know which x it is? It's automatically which x. If you have an attribute and a parameter and you just say x, which x is it? Can you tell from this? Is it the parameter or is it the attribute? Attribute. It's this little x right here on the right. Which x is that? That's the parameter. If you want it to be the attribute, what do you say? This dot x. Now, is everybody with me on that? That's some Java stuff that you need to know. Does everybody see how that works? The way you distinguish between those if they have the same name? Okay. So that's a construct. Okay, and now here's another. Oh, point. Same name as this. This must be another what? This must be another what? Constructor. So now so we're overloading. You're with me? Based on the types of on the signature, right? So here's another constructor. Only this time, instead of having two parameters, each of type int, it has one parameter, p of type point. Right? And now, what does this constructor do? It calls the above constructor by saying this, p.x, p.y. Right? So this is a call to this constructor, which sets this x to the p.x and the attribute y to the p.y. Is everybody with me on that? See how Sestov has these really good, succinct, no fluff. I mean, you know, just he gets right to the point. Yuck, yuck. Anyway, that was purely unintentional. And then move. Now, what does move do? We're given a what? Dx. A dx and a dy, both of ints. And then what does it do? This attribute x gets x plus dx, and y gets x plus dy, right? Plus gets, just like C++. Are you with me? And here is a method called what? What's the name of this method? ToString. And what does it return? Type string. Are you with me? And what string does it return? It returns, now what is this? A left parentheses, and what does this plus mean? Concatenated, because it's a string. So it's concatenated with what? X, which is this X, okay, so that's an int. But an int has a toString, its own toString, so the value of X comes out. Plus, it concatenated with what? A comma. Is that a space after the comma?
Yeah.
I think so, maybe. Concatenated with Y, concatenated with the right paren. And that's what toString. This X is this attribute X of the point. Are we good?
Oh, sorry, can you explain the point again?
Sure. All right. Do you understand that this is a constructor, just like this is a constructor, but it's overloaded because the signature is different. Remember what the signature is? It's the what of the parameters. The signature is the number of parameters and their types. Are you with me? So this has a different signature. This has two parameters, each of type int. This has one parameter of type point, class point, right? So that's function overloading, like we did in C++. And so whenever you call a constructor, if you give it just a point, this constructor will be called. If you give it two ints, this constructor will be called. And what's interesting is this constructor actually, when you say this parentheses, that calls this constructor. Do you see how that worked?
But I thought this meant it called the action.
Oh, no. No. Well, yeah, this, yeah. It's like this in Java is like this in C++, except in C++ this is always a pointer. And in Java the pointers are not explicit. They're implicit. So this is this object. So when we say this, we mean the constructor for this one. Whereas when we say this, we mean the X attribute of this one. Yeah, you're right. It's a little confusing, isn't it? Because it's two different uses of this. I mean, it's this in two different contexts. Yeah, good question. And now let's see if we can predict what the output is here. So here's class example 12. Public static void main string args. Now what are we doing here? Point P1 gets what? New point 1020. So P1 is a point with X of 10 and Y of 20, right? And then P2, new point 3040. And then system.outline P1 is, now what is this? Concatenation. And now we don't have to say toString. When we just say P1 and we output that string, what's going to come out? What's going to come out? ToString is going to get called automatically. What's going to come out? Somebody help me out here. Parentheses, X. Yeah, which will be 10 and then comma 20, right? And then same with P2. And then we're going to do P2.move 77. And then system.P2 is what? So what will the second value of P2 be? It'll be 1020 and then 3040 and then what? Come on. Then what? Yeah, 3747. Are we good? All right, let's try it. Okay, here comes the big demo. That was example 12, right? So let's give us some space here. And we'll take a look at, we'll run example 12. And there it is. 10, 20, 30, 40, 37, 47. Is everybody happy? All right. Next one is example 18. Now this one shows, now remember how, we're doing this because remember how we had random, remember how we used the random delays? So this shows how math.random works. So math.random returns a double value with a positive sign greater than or equal to 0.0 and less than 1.0. So let's see. You know how do we notate that mathematically? Isn't it like this? Isn't it 0? Isn't it this? 0, comma, 1. You familiar with this notation in math? Yeah, this one's inclusive of 0, and then this one is exclusive of 1. So isn't that what that is? Okay. So let's take a look at the code and see if we can predict what comes out. Public static void main string. Oh, here's a comment. Roll a die, count frequencies. Oh, I don't think we're going to be able to predict this. So now let's take a look at what this code does. We have int bracket. Now, because we have int bracket, that means this is a what? A what of what? It's an array of ints. Exactly. It's an array of ints. And so freq, which stands for frequency, is an array of ints. And it's new int 6. Are you with me? So that means there is a freq sub what? Sub, what's the first one? Sub 0, 1, 2, 3, 4, and 5. Yeah? And then all initialized to 0. And then for int I get 0, I less than 1,000, I plus plus. And so we're going to run this loop 1,000 times. And each time we run it, what's going to happen when we do math.random? That's a number between what and what? 0 and 0.999999, right? And then 6 times that is between what and what? 0 and no. 6 times a number between 0 and 0.99999 is a number between what and what? 0 and 5.99999, right? Are you with me? And then 1 plus that is a number between what? 1 and 6.99999. Is everybody with me on this? This is higher math? Is everybody good? All right. And then int does what? Int in the parentheses does what? What's that called? Yeah, what's it called? There's a word for that. Type what? Typecasting. That's typecasting. And so that chops off the points. So that's an integer between what and what? That's an integer between what and what? 1 and 6. Is everybody with me on that? Is between 1 and 6? Is everybody good? It chops it. It chops it. If it rounded it, we would have 7. Are you with me? It chops, it discards the fractional part. It's the floor. Yeah, but that's why we added 1. Yeah. So are you with me on this? Is everybody clear on this? Math, okay? All right, so therefore it's between 1 and 6. Yeah? So that's the value of die. And then frequency sub what? Die minus 1 plus gets 1. Is everybody with me on that? So what that does is, if the number was 5, then die sub 4 gets die sub 4 plus 1. And so it's counting how many numbers come up in each one. Does anyone want to? And then for int c gets 1, c less than or equal to 6, c plus plus. So a new little variable here just to keep us from getting confused. System.println c came up frequency c minus 1 times. Now, hopefully if it was perfectly, I mean, well, I can't say they would be the same if they were perfectly random, but each number should be approximately what? 1,000 divided by 6. Does anybody have a calculator? Can you do 1,000 divided by 6? Say it again? 167, is that what it is? 1,000 divided by 6? Okay. So it should be around there. It should be around there. We'll see. And now as another example, continuing, create an array of the strings A0, A1 up to A19. So this doesn't use any random stuff. This is just for int I get 0, I less than number dot length. Wait, what is this doing? 20 new string 20. So this is a string of 20 numbers, and then it's Oh, and then it's concatenating the letter A with I from 0 to I++, and then it's outputting them. All right? So let's run this and see what happens. Which example was that? 18? Okay. Let's run 18. Oh, look at that. What did you say the number was supposed to be? 167. So it's right around there. 180, 154, 180, 159, 173, 154. And then there's all the letters A0 to A19. And if we run it again, these numbers are going to be different, right? If it's really random. See? 168, 156, 166. Yeah. See how that random number generator works? And here's another one. 185, 180, 152.
They could all be in the first one.
They could, if we ran this a million times, maybe it'll... Sometimes when I play backgammon, I think that the dice are loaded against me. But that's the way the old random numbers work in real life. Okay, so those were some interesting... Oh, and by the way, like I said before, I've made available, that's something I did new this year. All of the software now is, we used to do it on the command line up until this year. Now it's all done in NetBeans because we have this great NetBeans plugin for C++. So I just went ahead and converted everything to a NetBeans project. It's going to be a whole lot, you guys are going to have it a whole lot easier than the guys last year had it because of that. So you can download each one of these. It's on the web page. Okay, now the next thing we need to learn about is about how exceptions happen, right? And so this next now let me say a word about an exception. So what does the English word exceptional mean? Hmm? Great. Oh well, actually, that is one word. Yeah, great. Yeah, great. Really good. That was an exceptional performance. But why is an exceptional performance so good? Because it's so what?
Rare.
It's rare. It's uncommon. Uncommonly good. So that's so the whole point is that in software design, an exception is something that is out of the ordinary. In fact, instead of having a positive connotation like that was an exceptional performance, it has a negative connotation like something went wrong. So, and can you think of some things that can go wrong when a program is running? Some things that you wish wouldn't happen, but that happened. You know, maybe unexpectedly. What are some things that, like when you're doing math? What are some illegal things? Dividing by zero. That's an exceptional. Square root of a negative number, unless you're dealing with imaginary numbers, that can be bad. Those are things that can be bad. Or what's another thing that can happen with arrays? Out of bounds. Now, do you remember how in data structures we had to design our own safe array to check for out of bounds? But you guys know one feature of Java? Guess what? What would be really handy if we wouldn't have to make our own safe array in C++? What would be a really handy thing to have? Is to actually have the language have that happen automatically. Check for out of bounds automatically. That, in fact, is a feature of Java. And so if you go outside the bounds of an array, that's an exception that gets thrown. Okay, so let's take a look at this slide. The throw statement enables the programmer to detect that something bad has happened, and to indicate that, handle that by what's called throwing an exception. Okay, so and the statement is throw expression, and here you say. Here's the syntax. Throw is the keyword, and then expression is some expression. But the thing of it is that the type of expression must be a subclass of class throwable. All right? So Java has a number of classes that it has classified a certain way, and some of them are called throwable classes, and the type, whenever you throw an exception, you have to, it can't just be any old type, it has to be something that is throwable. We'll see a list of them here in a minute. You see what I'm saying? Now, look, with a baseball, if one person throws the baseball, what does the other person do? You catch it. So what happens is, one part of the program, or one part of the system, throws the exception, and then typically what happens is, the programmer who wants to take into account the fact that this bad stuff might happen can explicitly catch what got thrown. And we're going to see how that works. But that's the idea. The idea is that something bad happens, and then to handle that exception, then the programmer wants to be able to catch it. So the enclosing block statement terminates abruptly. So anytime an exception is thrown, then boom, at that point where that happens, it doesn't require an if statement. The if statements are all automatic. If it gets thrown, then boom, the enclosing block statement, that gets terminated right there. Okay, that enclosing block statement. Right? What do we mean by a block statement? It's open brace, close brace. That's the enclosing block statement. Yeah? And then the thrown exception may be caught by a try-catch statement. So throw works in conjunction with try-catch. Now, so here is, now I didn't put them all up here because that's really, really long. But here are some of the most interesting ones. Remember we said that the expression must be of type, a subclass of type throwable. So here is throwable. Now does everybody understand that the indentation here represents inheritance? So do you see then that out-of-memory error inherits from error, and error inherits from throwable? But exception does not inherit from error. What does exception inherit from? Throwable. So does everybody see that that's how you read the indentation with the inherits? Okay? So is out-of-memory error throwable? Yes or no? Yes. It is, because it inherits from error, and error inherits from throwable. Right? So it is throwable. And then here we have, so that's obvious what that means, right? Out of memory. You do a new, it's out of memory, oop, throw an exception. So if you want to check to see if there's memory left after you do it, you do a new, and then you catch the out of memory error if you want to check for that. Okay? And then IO exception, what does IO stand for? Oh my goodness. You guys, are you serious? Or are you just shy? IO? Input output. Yeah, okay, good. IO is input output, yeah. Okay, so that's IO is input out. So that's an input output exception. So like, I don't know, like maybe the disk failure, and you try to input from a disk and there's a disk failure. So maybe there's an IO exception. And then here's a runtime, and then a runtime exception inherits from exception, which inherits from throwable. And what are some of the runtime exceptions? Arithmetic exception. So what? And you said what some of those arithmetic exceptions were. What were they? What would fall under this category? Divide by 0, square root of -1. And here's index out of bounds. That's the other one that I explained before. Index out of bounds exception. And here is an array index out of bounds exception and a string index out of bounds exception. And a negative array size exception is also another runtime exception. So there's a whole bunch of them. And these are just a few of the ones to give you a flavor for that. So that's just a partial class hierarchy. And now here is the actual code of the try catch finally statement. Now this doesn't have the throw statement. The throw occurs in another piece of code. But if you want to handle the exception, what you do is you write what is called a try catch finally statement. And the key word here is try, and then you can have more than one catch. So you have try, and then nested inside the try is body, and then nested at the same level of the body but after it is catch E1 X1 and catch body 1 and catch E2 X2 and then catch body 2. And now what happens is this E1 and this E2, what are they? They come from this list of throwable exceptions. So you actually would put, for example, if you want to catch an arithmetic exception, what you would do is you would say catch arithmetic expression, arithmetic, what was it? Arithmetic exception. So you would say catch arithmetic exception, and then your variable here is the variable that has, it's the object, it's the variable that has this type. And then you can use this x1 in the body. Do you see how that works? Okay, so you're naming, so you can specify which ones you want to catch.
So you're saying that like x1 and x2 are type of whatever exception?
E1 and E2 are the types.
Yeah. And then x1
and x2 are, you can think of them as the variables.
Yeah.
You can think of them as the variables that have that type that you can then use in the catch body. See what I mean? It's like a parameter list. It's like a little local parameter list for the catch method. See what I mean?
So if we have two catch E1 types, that
No, you don't want to. You don't want to have two E1 and E2 have the same type. You wouldn't want to do that. Yeah, that's normally not done. Whichever ones because you want to catch this type here, you want to catch this type here. Okay. What if you did? Yeah. Okay. If you did, okay. That's the kind of question that I don't know the answer to, but that Java precisely probably has specifically how that works, and I will refer you to Sestov for that. Yeah. So, and then after these catches, so you have the body after these catches, then you can have finally, and you have a finally body. Now, what happens is frequently, in fact, usually, the finally body can be omitted. So it is frequently omitted in the same way that you can like omit an else, you know, when you have if, else if, and then else, or like default, you know, frequently, I mean, it's that kind of a thing. It can be omitted, all right? So frequently we'll just, in fact, what we're going to start with doing, just seeing how try-catch works, all right? Now, so here is try-catch with no finally. Here's what happens, you guys. Suppose you say try, and then you have this A, B, C, D, these are Java statements, right? Like assignment statements or some kind of computation statement. Are you with me? So try A, B, C, D, and then suppose you say catch E1, X1, and then we have F and G are the statements inside the catch body. And notice how we have the brace here, and the brace here, and the brace here, and the brace here. Yeah? Now, let's suppose that in statement B, that's like X gets 5 divided by Y. Now, what could go wrong? Y could be what? 0. And if it is, then there's going to be an exception is going to be thrown there, all right? So there's two possibilities. Here's one possibility. If there's no exceptions in A, B, C, and D, then when you hit the try, A executes, B executes, C executes, D executes, and if there's no exception, then the statements after that execute. So it's just A, B, C, D, and then the ones after that. Yeah.
So it's like if you have an error, do this, and not just do regular?
Yeah, exactly.
Okay.
So if there's no exception, none of the catch. If there's no exceptions there, then nothing gets caught, and it just does those, and then it skips all the catches and goes on.
They have this in C++?
They actually do. They actually do. The question is, do they have this in C++? And the answer is yes. Okay. Now, on the other hand, if there is an exception at B, like if a divide by 0 happens at B, and if this E1 is an arithmetic exception, then what happens is when it does A and B. Now look, you guys, what did it say back here on this slide? It says the enclosing block statement does what? Terminates abruptly. Now this phrase, terminates abruptly, means this. It means when you get to A and B, that means that C and D don't execute. It terminates abruptly, and if this E1 is the exception type that got thrown here, And by the way, the Java will throw that automatically. See, it will throw the exception there. And if you want to catch it, then you go here, and then F and G will execute. So the sequence will be A, B, F, G, even though there's no if statement. That's the big advantage of using exception handling with the try-catch statement, is that you don't have to pepper your code with if statements. Can you imagine having to say if y is equal to 0, then blah, 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 you know, because that doesn't, you don't want to have to check for that every time you do a divide. Yeah, you see what I'm saying? So this gives a way to control what would happen, you know, but on the other hand, you do want to be able to handle that if you don't have a precondition that would prevent it. See? So everybody see, that's the idea. All right? And now, I think this will be our last example. We're going to do Sestoft example 81, which uses Sestoft example 89. So here again, I packaged this up into a Java package with example 81. And so let's take a look at the code. There's some statements in here about a version number and about super and about passing a string to the constructors of a superclass. So we'll come back to this in a minute after we take a look at this code. Now, so example 89.java is it's called class. It defines a class. The class is called weekday exception. Now, this weekday exception is what the programmer came up with. This is not a built-in Java exception. The programmer wants to program weekday exception. You see what I mean? And what's he saying? What does it extends mean? Inherits from what? Exception. Now, where was exception on that list? Look, it's exception, which is what? Inherits from what? Exception inherits from what? Throwable. So that's throwable, right? So he's making his own. Instead of being an IO exception or a runtime, it's a weekday exception that he's defining, the programmer is defining that exception. Did you see how that worked? Okay, how that works? And now, and here's this comment about the version number. Static final long serial version UID equals 50L. 50 is an integer, a long int. 50L is a long int constant. And I don't want to get into this, but the only reason I put this in here is because the only reason he puts this in here, did he put that in there? I don't remember now if he did that or if I did this. I don't remember if this is his code or my code. But anyway, if you don't put it in there, the compiler will complain with I think just with a warning. So okay, that's for version control. All right. So anyway, class weekday exception extends exception, and then here we have this version number. And then inside this class, we have public and then weekday exception. Now look, this weekday exception has the same name as what? As this weekday exception, right? You see what I'm saying? And so so it's kind of like a constructor, right? And what does it take as a parameter? A what? A string, a Java string, which is immutable. Okay. And what's the name of this string? WDay, which stands as an abbreviation for weekday, right? And what does it do? It does super, and then it says illegal weekday, and then end quote, concatenated with WDay. All right? So now what is this super? This super is, like it says here in this previous slide, super is a call to the superclass constructor. Now, who is the superclass of weekday? Who is the superclass of weekday exception? Who is the superclass of weekday exception? Subclass, superclass. Yes, exception is the superclass because it inherits from that. So does everybody see then that this is a call to the This is a call to exceptions constructor. Is everybody with me on that? Okay, so just structure-wise. Whoops. So just structure-wise. So super is a call to the superclass constructor. And here's the effect of it. What are we doing? We're passing a string. So when you pass a string to the constructor of a superclass, that causes toString to append the string to the name of the exception. All right. Now what was toString? Remember we did the, I know we're going through a lot here, but what was toString? That was the default. If you just, that's what gets printed out when you system.out.println that thing, right? That's what, so what does this do? This appends, that's going to append what? That's going to append this string to the toString of exception. Are you with me? So that if we want to print out our exception variable, that string is going to come out without the explicit call of saying toString, just like before. Are you with me on this? Okay, so here's what let's do. Let's demo this. Let's demo, I'll tell you what, let's end with this demo and we'll continue with this tomorrow where we left off here. But I just wanted to show you this one demo. Let's Java example 81 with Wednesday as the command line, as the command line argument. And then WDXX and then example 81. So watch this. That's example 81, right? If we go to example 81 and we take a look at the command line argument, notice here on run we have, oh, I don't have anything for the argument yet. Oh, that was because that was example 18. I clicked the wrong one. I thought, no, okay. So let's go to properties. Okay, and we go to run. And here, arguments is Wednesday. Do you see how that's the argument? So now what happens is if we run example 81, if we run example 81 with Wednesday, what happens is it says Wednesday is weekday number 3. You know, we can't understand how this works unless we actually look at the code for example 81. Did we not look at that? Oh, here's the code for example 81. We should have looked at that first. Okay, well, it's way past time. All right, so we'll pick up here tomorrow, right where we left off. All right, good deal. Oh, and if you want your exams, I've got them. So you can come by and pick them up. All right, see you next time.